Begin P6. No, these are probably yours. Somebody left them this morning. Are those yours?
Yeah.
Okay. All right. So here we are in P6, which is a short little section. We'll probably get it all done today. Very, very easy. In one of our problems, I think it was yesterday, we ran across, we had a problem that had like a square root in it, like of a negative. Do you remember that? And how did we say we were going to handle the square root of a negative? Bring out the negative and you bring it out as an I, right? An imaginary number. So this is what we did. The negative came out as an I. So that's what these I's are. These I's happened because at some point we took the square root of a negative. But when you're working with them, you treat them just like any other variable. So if you want to add these two things together, it's super simple. You just combine like terms. So the answer to this would be 5 minus 3i. Does that make sense to you? Easy. So the next one, they're being subtracted. Well, that's the same thing, except because this is a minus, what do we have to do first? Distribute the negative. So we have 4 plus 3i minus 6 minus I. And we just collect our terms. So that would be negative 2 plus 2i. Easy? Yeah. All right, now the next one is a multiply. Now take a look at that scenario. This is a multiplication. What do you think we're going to do? Foil. Foil. So first times first. Outsides, insides, and lasts. Remember, when you multiply an I times an I, you get an I squared, just like you do with X's or anything else. Okay, now what about these middle two? They can add up to be negative 1i. So you can either write negative 1i or just negative I. Doesn't matter, whatever works for you. But now there's something you have to remember, something new maybe. You did it last year, but you may have forgotten. Anybody remember what's special about an I squared? It changes to a positive, not to a positive. I squared, write this down and put a circle around it. I squared is negative 1. So every time you see an I squared, oh, so Brendan, I see maybe what you're talking about. This is going to turn into a positive 6 because it's negative 6 times negative 1. This is a negative 1. So that's going to actually become a plus 6. Which then will add to the 12 in the front, and it's going to be 18 minus I. If you put negative I plus 18, that's fine. We usually put the I last, but again, it really doesn't matter. So every time we see an I squared, we're going to make it a negative 1. All right, guys? Every time we see an I squared. All right, and our last problem here in this little section is a division. Does anybody remember anything about dividing complex numbers? These kind of numbers with with I's in them, those are called complex numbers. Anybody remember how to divide them?
Do you multiply the bottom?
And the top by what?
The bottom.
Close.
Like the opposite.
Well, change the middle sign. That's right. We call it the conjugate. The conjugate. The conjugate of the denominator. And when you write the conjugate, you change just the middle sign. Okay, just the middle sign. So the conjugate of 6 minus I is 6 plus I. The conjugate of 3 plus 2I would be 3 minus 2I. So we multiply the top and the bottom, gotta do both, by the conjugate of the bottom. So Ejani was right, we look at the bottom. That's the one that matters. So we're gonna multiply the top and the bottom by the conjugate of the bottom, okay? Everybody with me? Now, it's a huge problem because now what do we have to do on the top? Foil. And what do we have to do on the bottom? Foil. So we just gotta do a bunch of foiling now, just like we did there. So if I do the top, it's 30 first, outside, inside, last. And then I'm gonna foil my bottom, first, outside, inside, last. Don't rush, take your time. Multiply first, outsides, insides, and last. Okay. Now what? We just start cleaning it up, right? All right, we just start cleaning it up. So let's look at the numerator. Can these two be added together?
Yeah.
So that's gonna make a what, 23? And then, what about this I squared right here? It's -1, so this is gonna become -3, which is gonna add to the 30 and make 27. So on the top, I have 27 plus 23i. Does that make sense to you? Okay. Now, here's the reason we did what we did in the beginning with the conjugate. What happens to these two terms? They are gone. And what happens here? What is -I squared? Actually, it's +1, isn't it? Isn't it -1? So this is gonna become a +1, so what's my denominator? Just 37. You are not allowed to have an I in the denominator of your problem, of your answer. So by doing this operation, multiplying the top and bottom by the conjugate, it turned the denominator into just a regular number. That was the goal. I's are fine up here, that's okay, but not in the denominator, so that's how we took care of it. Okay? This is kind of like, the other day we did our quadratic formula. If you get something like this, remember how you're supposed to take a 2 out of everything? This triangle here? This is the same situation. There's a triangle of numbers. So if you have one that you can cancel, remember you must cancel out of all 3. Okay, so if you end up with, 22 plus 4i over 11, don't cancel these because you have to be able to cancel all 3. Okay, all right, good, perfect. All right, next, square root of -81. Okay, well that's easy. What's the square root of -81? Okay, and what's the square root of 81? 9. So the answer is 9i. So we pull the negative out as an I, and then we have the square root of 81, which is just 9. This is exactly the same thing, guys, only there's 2 of them. What's this equal right here? What is this equal? 2i. Everybody okay with 2i? What's this equal? 3i. So what happens when I multiply them together? 6i squared. And what about I squared? I squared is -1, so this just becomes 6 times -1, or -6. Whenever you have a negative under a radical, don't do anything until you've pulled it out. So the first thing that has to happen when I see this is the negative has to come out. All right, and then I can go on with my problem. All right, that seems easy enough. All right, let's look at number 2. Problem number 2. Find the value of x and y. Don't make this hard. This is the easiest problem ever. Look at it and what makes sense. What just makes sense if these two things have to equal each other? What do you think x equals? 3. Exactly. Don't you have 3 plus 2i equals x plus yi? Doesn't it make sense that 3 and x are the same? And then what's y? 2. It's that easy, kids. Do not make that complicated. If this side is the same as this side, then the I part has to match up, so that has to be a 2. And the non-I part has to match up, so that has to be a 3. So the next one looks more complicated, but it is not more complicated. What's x? 3. Now be careful with the y. Does it make sense to you that this and this have to match? So if negative y has to be 7, then what's y? This right here has to match this. They're both hooked to the I, so those two have to match. So whatever number this is has to match this number right here. So if negative y has to be 7, then regular y has to be negative 7. Whatever, so think if your number looks like this. Whatever is at the front of the problem, here and here, has to match. So whatever's in those boxes, in this case it's a 3 and an x, those have to match. They have to be the same. Whatever you have attached to the I has to match. So on this side we have a negative y attached to the I, and on this side we have a 7 attached to the I. Those have to match for the numbers to be equal. All right, here's a review problem. Well, how do you want to solve it? You've got a couple of options. What do you think? You could complete the square. This one's set up beautifully for that. What would be the first step if we're going to complete the square? Move the 2 over. Now what?
So divide the 4 by 2.
I have to figure out what I'm going to add to both sides. And I figure that out by taking this number divided by 2 and then square it. So 4 divided by 2 is 2, but squared is 4. I'm going to add 4 to both sides. Then I write this as a square. What square is this? We know it's going to be x. We know know it's gonna be plus
Two.
2. Because 2 squared has to give you that number that you added. And that equals 2. Alright, so what happens now?
Square both.
Square root both sides. So x plus 2 equals
2.
plus or minus square root of 2. And then we subtract, so x equals -2 plus or minus root 2. That's just a review problem, I'm not sure why I stuck that in there. We okay? Alright, we got one more review problem, it looks like. I don't think I wanna complete the square on this one. Can somebody tell me why my lazy self does not want to complete the square on this problem?
Take you on the fractions.
I don't wanna deal with the fractions, and I'm gonna have a fraction if I complete the square, because what's the first thing I'm gonna have to do? Divide by 2. And with a 9 and a 7, that is not going to be pretty. It's possible, doable, but I don't wanna do it. So instead of completing the square, maybe I will quadratic formula. So who can tell me the formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you unwisely came to class today not knowing that, make sure you get that memorized. Alright, so here we go. Negative b will be, Kayla, you paying attention, sweetie?
Yes.
I am right on the edge of having you sit right here in front of me, because I just think that would be more fun. So, positive 9 plus or minus the square root of 9 squared minus 4 times 2 times 7 all over 4. Am I good with everybody? Okay, so now I'm gonna clean up a little bit here. Let's see. 4 times 2 is 8, times 7 is 56. And that's gonna stay a minus. Agreed? So 9 plus or minus the square root of, okay, 81 minus 56. Oh my gosh, is that 25?
Yeah. No.
Why am I just so excited about that? Because the square root of 25 is 5. So now I can actually work it out and get some answers. 9 plus or minus 5 over 4. Because the square root of 25 is 5. So 9 plus 5 over 4, 9 minus 5 over 4. Okay, here we go. 9 plus 5 is 14 over 4, reduces to 7 halves. 9 minus 5 over 4 reduces to 1. Okay. All right. Number 4 and 4A and B, we have already done a couple like these. Does anybody feel confident in coming up and doing either A or B? Anybody feel like you can do this one? Or this one? Maybe with a friend? Okay,
I'll do one.
which one do you want to do?
I'll do the.
The big one? Woo, what a brave man. Sincere, you want to do one? Are you guys together?
Yeah.
Yeah.
All right, Sincere, you gonna fly solo or you wanna bring a friend? You can do either one. shoot right nice and big, because we're on video, okay?
That is good enough?
Yeah.
Well,
Make sure it's picking up that red mark.
Yeah, I got you.
Hey, Gabe and Kais, you guys wanna switch to black? It'll pick it up. It's okay, you can leave what you've already got, but the rest of it do in black. Okay, and what are the rest of us doing here? We're working on them, that's right. What the heck is that?
Yeah, go ahead.
What's in this? Oh, okay. What was it? Looks like it had tomato or something.
It was spicy.
Spicy.
14 ice cream.
Not for me, thank you. I ate my oatmeal. Sincere, are you doing this or is she doing this?
He did the foil.
Okay, okay. Yeah, you're right. No, on the 13, no. That one's still there. He's right. Nice job. Perfect, guys, perfect. All right, they got the first one done, and I think it's okay. I think they did great.
Yeah.
On the first one. Did you guys at your seats remember on the second one to multiply the top and bottom by 3 plus 2i? We call that the conjugate. We're multiplying top and bottom by the conjugate. And then they have massive FOIL problems. And let's see if it turned out okay. I did not do this. Did anybody at your seats do this? And match them? Yeah, I think you guys got it. That looks really good, really good. As you're working through it, take a look at what they did. Do you have a question? Would you get 12? 3 times 4. Oh, you got this, you're not done. I squared is -1. I squared is -1, so anytime we see an I squared, we're gonna change it to a -1. Joshua, how you feeling about this?
That one, yeah, but that one.
So theirs is just like that one, only it's one on top and one on bottom. So what part of what they did is confusing you?
You got the I squared, the -4 minus 1. The -4 times -1.
Here,
Yeah.
okay, so they FOILed on the bottom, and when you multiply a -2i times a +2i, when you FOIL the L part last times last, -2i times +2i is -4i squared. So that's where this came from. But I squared is always -1. So this actually became a +4. So they had a 9 plus 4, and that's how they got the 13. You sure?
Yeah.
Okay. All right, anybody else? That's a 31, by the way, right there. That's a tiny little 31. Anybody else have a question? I told you this was an easy section. You feel pretty good about this section? Okay, so P6 will be due on Friday. Easy. due on Friday. All right? Now we're gonna do P7. We're gonna start P7. All right? There are lots of different ways to do this problem, and it kills me as a teacher who's supposed to be preparing you for calculus to do it this way, but I'm gonna do it the way you did it last year because I think that makes more sense to you, and so we're just gonna do it that way. So what you did last year when you saw this problem is you broke it into two different problems. Do you remember that? And the first one, you left it exactly as it is, but took out the absolute value. So you said x minus 2 is greater than 3. So you're gonna break this into two. The first one is exactly what you see, but take out the absolute value. Don't change a thing. The second one is the same on this side, but this becomes less than -3. So in your second piece, your first piece you're going, your second piece, you change the sign around and make this a negative. Do you remember doing that last year? No? Okay, well that's what I want you to do. Okay? Now, the word that goes in between a greater than problem, when your problem starts out as a greater than, the word that goes in between the two pieces is or. Now you're starting to remember it now? Yeah. So then we solve each piece. So we just solve this like regular. So we're gonna add 2 to both sides, and it's gonna say x is greater than 5. And then we add 2 to both sides, and it says x is less than -1. Then we go to our number line, and here's 5, open dot, right, open dot, shaded greater than 5 this way, and then on the same number line, -1, open dot, shaded this way. You okay so far? Now we're gonna write our answer in interval notation. So remember, this side of the number line is negative infinity, and this side of the number line is positive infinity. So what interval would this be? Using your parentheses or brackets, what interval would this be? Negative infinity, comma, -1, and they're both parentheses?
Yeah.
And then this piece is the same thing, but it's 5 positive infinity. And then since it's an or, we put our mathematical or symbol in there, which is the union symbol, or the U. And this is what you would write in the answer blank. So there's a lot of steps to that. We're gonna go through them again with this one. Now this one, we're gonna do exactly the same thing. So what's the first, I'm gonna break it into 2. What's the first thing I'm gonna break it into? X plus 5 is less than or equal to 6. Don't change a thing. Now, what's the second piece I'm gonna break it into. X plus 5 is greater than or equal to negative 6. Okay, we good so far? The word in between these two, because this is a less than, is an and. Now, what's that gonna change? Well, nothing in the beginning. What's this when you solve it? X is less than or equal to 1. Who said 11?
Oh, me, sorry.
Minus 5.
Sorry.
And then this one actually will be negative 11 over here. Now I'm gonna go to my number line. Here's my 1, solid dot, shaded this way. Here's my negative 11, solid dot, shaded this way. Now my answer has to be both of these. That's what that less than means, that and. That means it has to be both of these. So where is my answer if it has to be both of those shadings? Isn't it in between? Right there? Where they overlap? So if this is my answer, how will I write that in an interval? Well, those are closed dots. Sincere?
Negative 11, I think it's greater than, equal to?
Oh,
Or
if
less
I'm
than?
gonna write it as an inequality, I'm using my brackets and parentheses.
Oh, okay.
So what would that be? Negative 11 comma 1. And then what would be on either side?
Right.
Brackets. Does everybody understand why I'm not using infinities in this problem? In this problem, this is the answer, right? Not the ends. Only when the ends are the answer do I use infinities. Okay, there's a lot to remember. All right, let's look at C. It's exactly the same setup, guys. Please don't think because there's like a 2 or something in it that matters. It doesn't matter. It's exactly the same setup. So, Taylor, what's the first thing I'm gonna write? Okay, let's look over here at this one that we just did.
Drop it out of that.
Drop it out of the absolute value. So the first thing is just drop it out. So it's gonna be 2x minus 8 is greater than or equal to 7.
Yeah, and then you flip it. Now you have two.
So then I write 2x minus 8 is less than or equal to negative 7. I flip it and make it negative. Everybody okay?
Yeah.
Jocelyn, you okay? All right, what's the word in between this time? Pay attention to that sign. What's the word in between? It's an or. The greater than is or. The greater than is or. The less than is and. Greater, or, less than, and, kind of dumb, but somehow you gotta remember, right? Okay, here we go, let's solve. So we'll add 8 and divide. So I got 15 halves. You can say 7.5 if you want, doesn't matter, one bit. And then over here, I got 1 half. So I'm gonna go to my number line. 15 halves, or 7 1/2. That'll be closed dot. Shaded which way? Right? Pointing that way. And then here's 1/2. Make sure you get these in order. 1/2 is less than 15/2, so be over here. Solid dot, shaded this way. So my answer's in 2 pieces, right? So here we go. What's the interval notation for this?
Negative
Negative infinity, comma, 1/2, bracket, union. Second piece is bracket, 15/2, parentheses, infinity, or comma, infinity, parentheses. All right, you ready to tackle the next one on your own? All right, let's do it. That's your seat. Do it. See what you can come up with. Break it up into your 2 pieces. Solve each piece. I've got my first step done. Would you look up here and just make sure this is what you've got before you get too far into the problem? Like Taylor said, we just drop out the absolute value, and then we change this, oh, I don't know where that came from. Change that around and make it a negative. Is that okay with everybody? Okay, go ahead and solve. Now, when you're solving this one, you do have to remember something. Did you remember when you divide by a negative, you turn that sign around? Because to solve for x, don't we have to divide by -4? And when you divide by -4, you've got to change the symbol. So after you get them solved, look up here and see if you match. I got x is greater than -3/2 for one side, and then x is less than 3 for the other side. So now I'll go to my number line. So here's -3/2, open dot, shaded this way. Here's 3, open dot, shaded this way. Now that's an and. So what do I need? My answer has to be both shadings. So where is the answer? In the middle. So I'm not gonna get a 2-part answer. I don't have 2 pieces, I have 1 piece. It's this piece in the middle. So parentheses, -3/2, comma 3. You feel okay about that? All right, we've done a lot today. We're gonna do one more, because it's a different kind, and maybe 2 like this, and then I'll stop, okay? All right, what's different about problem 2A? What's different about problem 2A? It's not even absolute value, right? So we're not gonna get this mixed up. It's a different kind of problem. It looks totally different. Ayrton, you awake, sweet pea? both you guys up here. All right, here we go. Any thoughts on how we would do this problem?
Subtract the 5.
Well, if you decided you were gonna complete the square on it, that would be a strategy. All of the problems like this that I give you are gonna be easy, and they're all going to be factorable. Can you factor that thing? And by factor, I mean like unfoil, break it into 2 parentheses. What would those 2 parentheses be? X and X, plus and minus. Now, it has to times to 5,
1 and 5.
and yeah, it's gotta be 1 and 5, and the 5 will have to be negative. So that when you FOIL it, you get a -4 in the middle. Am I speaking a language you somewhat recognize?
Yeah.
So step 1, I want you just to factor it. And they're gonna be easy factoring problems. Now, draw a number line. And on the number line, plot -1, because that's what this one would equal, right? This one would equal -1, and this one would equal 5. So on the number line, put an open dot at -1 and an open dot at 5. Everybody okay so far? Understand why the dots are where they are and why they're open? Okay. Now, I want you to pick a number that isn't -1 or 5. Pick any number that's not -1 or 5. 3? Okay. Would you agree that 3, the number you picked, is in this section? So if you were to pick 7, it would be out here or something, you know, this is the section you picked. Okay, go back to your problem, and you can go back to the original, or you can go back to the factors. I like to go back to the factors, and put in 3. If you put in 3 here, what do you get for this parentheses? 4. Times, okay, put in 3, what do you get here? -2. If you multiply 4 times -2, does that turn out bigger than 0? Does that answer turn out bigger than 0? What's 4 times -2? -8. Is -8 bigger than 0? No. So the number you guessed didn't work in the problem. So you do not shade the area where the number was. If that section isn't part of the answer, this section will be, and this section will be. Think about the problems that we just did. Didn't we have a couple problems where we shaded the outside part? And then we had a couple where we shaded the inside part? So you're either gonna get the outside or you're gonna get the inside. We're not sure when we look at this problem which way it's gonna be, so we check. You happen to check the middle part. You picked a number in the middle. It didn't work. 4 times -2 is not bigger than 0. So, since that didn't work, that meant these two would. Oh, we got 3 minutes of class left. Welcome. Okay. So now I have to write my answer. This section didn't work. That automatically means these will. One or the other. It's inside or out. So how do I write my final answer then? -infinity, comma, -1. And they're both parentheses, because that's an open dot. This one's always a parentheses. Union 5 infinity. So the answers are always going to look just like the absolute value answers, but how you get it's different. It's always going to be the middle part or the outside parts, but how you get it is going to be different. All right, that's enough. I can't do another one, so I will just stop there. So what have we got? P5 is due tomorrow, and